Hi, I'm Adolph Oliver, and in this lesson we're going to look at solving multiple step equations. Equations are going to take more than one operation to solve. And remember, of course, we've been talking to you that equations act like balance scales. They have to have something in both sides of the equal sign, and anything you can do with a balance scale, you can do with an equation. They're completely equivalent in that respect. Now the goal is to simplify the equation so you can say the answer directly. And so what we want to end up with here is something like I've got right here, x equals whatever number the answer turns out to be. Well, this allows us to focus on an advanced way of being able to solve these equations. Notice that this answer over here is going to be some number. Okay, that means, of course, then, that in our final speaking of this, we're going to say x equals whatever number the answer happens to be. Well, what this tells us then is that we want to have just terms with x on the left and just terms with numbers on the right, and we can use this as a guide to be able to see who we've got to move to do the solving. Well, let's look at this equation up above. We've got two terms on the left, one of them that has an x in it, this is 5x. The other term is -6, that's a plain number. And of course the 49 on the right side is a plain number. Well, plain numbers are what we want on the right side, so this guy is okay. Terms with x is what we want on the left side, so this guy is okay. The only one that's out of place here is this guy right here, which I'll circle. He's a plain number, but we don't want plain numbers on the left side. We only want terms with x. Well, what we can do now is say, okay, what I've got to do with this number is move them over to the side that I want them to be on. Remember, we want numbers on the right side here in our final answer. Well, here's a trick that we can use. Earlier on, we mentioned, of course, what we can do to get rid of someone that's -6 is add 6 to both sides. Well, we're going to do the same process here, but we're going to shortcut it a little bit. Here's the idea. Anytime you jump a term from one side to the other of the equal sign, you change its sign. So, let's take this guy and jump him over to the right side, and that means the -6 becomes +6. Now that's the same thing as writing down +6 on both sides here. All we're doing is we're saving ourselves writing a little bit, and that's what a lot of the shortcuts in math are, being able to get the answer without writing as much. So we wanted to move this -6. We moved him over as +6. So he's been moved. He's no longer on the left. What I have left now is 5x equals, and on this side, 49 plus 6 is 55. Well, notice, of course, now I've just got terms with x on the left and plain numbers on the right. I don't have to move anybody else. There was only one guy I had to move here, and we did that. Now, once you do the moving like this, then the last thing you do to solve is any multiplying or dividing. And since I have 5 times x here, I have to get rid of the 5 times. Well, the opposite of times is divide. So I divide by 5, but if I have to divide the left side by 5, I've got to divide the right side by 5. Well, these 5's reduce out. That's exactly what we wanted. And so I end up with x on the left. I'll write it over here where I've got a little bit of room. And of course, 5 goes into 55 11 times, so 11 over 1, x equals 11. Well, we're going to make use of this new idea of moving things to get them on the correct side as we go along. It's a little advanced way of being able to think about how to solve these equations, but now there are some other details we have to talk about. Here's one right here, okay? One of the things is you often have parens on one or both sides of the equations. And when that happens, of course, the parens mean that we need to do the distributive law to multiply in. You don't know exactly how much of each term you have until you do that. So one of the things we're going to find necessary is it's often necessary to clean up both sides of an equation before you start solving. As I said, you need to know exactly how much of each term you have, and so use the distributive law to remove any parents and then collect like terms. Well, okay, here we go. You do the cleanup each side separately. So we're going to take this 6 and distribute it in. And on the left side, 6 times 6y gives me 36y. 6 times -1 gives me -6. Now, let's clean up the right side. We distribute the 7 in. 7 times 5y gives me 35y. 7 times -2 is -14. Okay, well, now I know exactly how much of each term I have. I've used the distributive law to get rid of the parents, and now I'm ready to solve. Now, the next thing we do here is figure out who we have to move. Now let me write it over on the side here, but our goal, of course, is to be y equals whatever number the answer happens to be. In other words, I only want y terms on the left side. I only want number terms on the right. So what I'm going to do is circle the guys that are on the wrong side. Let's look at the left first. Remember, I only want y's on the left. Well, 36y is okay. But you see this -6? It has to move, so I'm going to circle it. On the right side here, we only want numbers. Well, the -14 is a number. It's okay. But the 35y has to move. So what I've done is I've looked at what our goal is. We want to end up with y equals whatever number the answer is, and I've used that to identify who has to be moved. I only want y's on the left, so the -6 has to move. No y's in it. I only want numbers on the right side. Well, the -14 is okay, but the 35 has some y's. Now move these. Well, the -6 goes over as +6. Remember, anytime you jump the other side of the equal bar, that changes the sign of what you're moving. The 35y over here is officially a +35. You don't see a sign in front, so you assume plus. When we jump it over, then it becomes -35y. So, notice what I've done. I've moved the guys that are on the wrong sides. The -6 jumped over to be +6. The +35y jumped over to be -35y. Now, let's see what we have left in each side. These guys that I've moved no longer are there anymore. And on the left side, I've got 36y minus 35y. Well, that's just one y. We're going to get the answer directly in this problem. And over on the right side, -14 plus 6, negative wins by 8. So y equals -8. There we've got the final answer now in the exact form that we want to have it. Okay, well, we'll use this distributive law in many problems to clean out parents so we see exactly what we've got of each term. Then we'll turn around and identify who's on the wrong side. We do that by thinking about what we want for the final answer. And then the guys that are on the wrong side, we jump them the other side of the equal bar, which then causes their sign to change. Well, okay, here's another problem we run into in working with equations. We can solve equations that have fractions and decimals in them, but the problem is that those fractions and decimals, if there's a lot of them, get to be kind of cumbersome to handle. So if there are a lot, it is often easier to clear them out before you start solving. And we'll run into problems where that's a good idea to do it. If you only have 1 or 2 fractions or decimals, you can often keep them and work it. But if you have enough of them, it's worth clearing them out. Well, to clear out fractions, we multiply through by the LCD. We'll give you a demonstration of that in just a moment. To clear out decimals, we multiply through by a power of 10. What I mean by a power of 10 is 10 to the first power, which is 10. 10 squared would be 100. 10 cubed would be 1,000, so on. Now, one thing you want to be careful is to do this to every term in both sides of the equation to maintain the balance. Even terms that don't happen to have fractions or decimals, if you decide to multiply through by the LCD or a power of 10, you've got to hit every term no matter what. Let's look at a couple of examples of these before we start looking at the main problems here. Now, Let's look at this first guy. Here we have an equation which has a couple of fractions in it, and they have different denominators. Now, you could solve this keeping the fractions in, but especially since they have different denominators, it's often easier to multiply through by the LCD and come up with an equivalent equation which has the same answer, but we don't have fractions anymore. So let's demonstrate that process to you. Now, here's the first thing that's a good idea. There's one term here that doesn't have a fraction in it. One of the things that folks often forget is when they multiply through by the LCD, they will often say, well, this guy doesn't have a fraction, so I don't have to multiply him. Well, that's completely wrong. The balance scale has to be maintained, so if you start multiplying through, you've got to hit each and every term on both sides to maintain that balance. So here's something I suggest. If there's any term that doesn't have a fraction, make a fraction by putting a 1 underneath it. Now it looks like it's got a fraction, and hopefully, that'll direct you to go ahead and multiply through all the terms, including the 6. Well, the next thing now, since we're going to clear all the fractions out the whole way, we look at all the denominators across on all the fractions on both sides together. This is not particularly difficult here. The LCD between 4 and 3 is 12. Remember, start with the 4 and think of the multiples of 4. The first multiple of 4 is 4. 3 doesn't divide evenly into that. The second multiple of 4 is 8. 3 doesn't divide evenly into 8. But the third multiple of 4 is 12. 3 does divide evenly into 12. So our LCD is 12. The reason why we start with a 4, the largest denominator, is we just get that LCD quicker. Okay, so our LCD here happens to be 12. Okay, well now what you simply do is multiply each and every term by that 12. I like to write it right up on top and circle it so that it's very blatant and you don't miss it. And what you got to do is make sure you hit each and every term once and only once. So there were 2 terms on the left, I hit both of them. There was only a single term on the right, so I hit it. Now what you simply do is reduce the denominators against that 12. Well, the first guy didn't have a denominator. He's 1, so the full 12 remains. The second fraction has got a 4. Well, 4 goes into 4 once, and in the 12 it goes 3 times, so that leaves a 3 from that 12. Going over the right side, I want to divide out the bottom. 3 goes into 3 once, and it goes into 12 4 times. So what I've done is I've reduced out those fractions that had denominators, and I've canceled them against that LCD I had up on top. Now you carefully go back and put the leftovers together. In the first term on the left, I've got 6 times the full 12. That gives me 72. The next fraction here, I've got the sign minus times 3 times 1, that's negative 3, and then of course there's a z, so negative 3z. Again, you put all the leftovers together. Let's look at this once more. There's a minus sign, then there's a 1, then there's a times 3, and then there's a times z. So that's negative 3z when you multiply that all together. Then we have the equal sign, and over on the right we've got 2 times 4, which is 8. Okay, well here we are. We're now ready to solve it. This equation right here has exactly the same answer as this original one. But now we don't have fractions anymore, and the rest of the solving is going to be a lot easier to do. Now, once again, remember what our goal is. I'll write it over here on the right side where I got a little bit of room. Z equals whatever number the answer is. So that means I only want z's on the left. Well, this term negative 3z has a z in it, but this 72 doesn't, so I've got to move it. So I circle who has to move. Okay, over on the right side, we only want plain numbers. Well, the 8 is a plain number, so it's okay. There was only one guy that had to move. Now, officially, that 72 has a plus in front of it, since we didn't see a sign. I need to move it to the other side where numbers belong. And when I jump at the other side of the equal sign, the sign of the 72 changes and it becomes negative 72. So it's been moved. Plus 72 became negative 72. Now let's see what's left on each side. On the left side, I've got negative 3z. On the right side, negative 72 and positive 8. Well, it turns out that negative wins here, and it's going to win by what? Looks like it's going to win by negative 64. Okay, so there we go. Negative wins by 64 when I combine these two guys. Now, the last thing to do on this, to solve for the value of z, is to divide both sides by negative 3. Why do we do that? Well, I want the answer z equals. I don't want negative 3 times z, so we're going to divide by negative 3, but we have to do the same to both sides. The 3's cancel out on the left. The 2 minuses give me a plus, so here's my officially plus 1z. I'm not writing the plus or the 1 in front. You can if you want. Let's see what we get on the right side here. The 2 minuses give me a plus. Now, if this had been 63, for instance, I could have reduced the 3 into 63, but 64, it doesn't reduce. You don't need to make a mixed number out of this since it's not a word problem. We can turn around and leave the answer as an improper fraction. So I'll go ahead and do that. Here it is, 64 thirds. But it was necessary that you took these two minus signs and combined them to a plus. Okay, well, there we go. Again, the idea was we started out up here by figuring out what the LCD was. Then we multiplied each term and both sides by the LCD, cancel out the denominators, ended up with an equivalent equation here, which has exactly the same answer as the original guy. And then we determined who we had to move, the 72, jumped it over the other side, and the last step is you either have to use multiply or divide to be able to come up with your final answer, and we got z equals 64 thirds. Now, let's look at a guy here where we've got some decimals. Decimals aren't nearly as much trouble as fractions are, but notice that in this particular problem, every term has a decimal, and some of them are to 2 places and some just to 1. So if you have quite a few decimals like this, and especially if they're different numbers of places, it's a good idea to clear out the decimals because it makes the rest of the solving easier to do. Well, here's what you determine. Just like in the fractions where we looked at everybody in both sides, look at all the terms that you have here and find the term that has the most number of decimal places. Well, this guy on the left has 2. This has only 1, so far our winner is 2 places. This guy on the right has 2 places, so that ties with the guy on the left. The other guy is just 1 place here on the right. So the worst number of decimal places we have are 2. Well, remember, to turn around and move the decimal point in the decimal number, you have to multiply by 10. If you multiply by 10, you move the decimal point 1 place. But we have to be able to move it 2 places to get rid of these guys that have 2 decimal places. So we have to multiply by 10 times 10, or 100. If there would have been anybody here with 3 decimal places, we would have had to multiply through by 1,000. So you need to find the power of 10 that will clear the most number of decimal places you have. The most we have is 2, so we can multiply through by 100 to do this. Okay, well, that being the case, what I'm going to do is write up above, just to remind myself here, 100 on top of each of the terms, because we got to hit everybody, whether they have decimals or not. In this particular example, everybody does have a decimal, but if there was anybody here that was just a plain whole number, we'd still have to multiply him by 100 too, because it's the balance scale principle we're maintaining. Okay, now let's clean this up. This first term on the left, multiplying by 100, moves the decimal point 2 places, so we officially end up with 103. Now look at this next guy. He's only got one decimal place. Well, the easiest thing to do is just put another 0 behind the 2 here. Now when you move it 2 places, we end up with 20 plus 20, and of course don't forget there was an x here. So now on the right side, the same thing. The first guy has 2 places, so we jump at the 2 places. We end up with 71. The second guy over here has only one decimal place, so let me just add another 0 behind the 6. Now I've got 2 places I can jump to, so he's going to be plus 60, and of course there's an x here. Okay, well what we've got now are nice whole numbers to be able to solve this, and this guy right here has exactly the same answer as the original guy up here. Okay, well the next thing we're going to do is we're going to remind ourselves what we want to end up with for the answer. I can write it down the bottom here. Let me do that. We want to end up with x equals whatever number the answer happens to be. Well, use this to remind yourself who you've got to move. We only want terms with x on the left, so the plus 20x is good, but the 103 is a plain number. Officially it has a plus in front, and I'm going to circle it because it's a guy we have to move. Over on the right side, we only want numbers. Well, the 71 is a plain number, but the plus 60x is not a plain number. It's got x's in it, so it has to move. So these are the 2 guys we need to move to work toward our final answer down here. Let's move them. First off, the 103 being positive, when I jump it over here, becomes negative 103. Okay, the plus 103 became negative 103, so I've moved the 103 over here. I'll cross it out. Now, the plus 60x over here, it also has to move over to this side. The plus 60x becomes negative 60x. Now let's double check that. Plus 60 became negative 60. That's correct. So I've moved it. I cross it out. Okay, let's see what we end up with. Over on the left side, I've got plus 20x and negative 60x. Negative's going to win by 40. So we have negative 40x. Over on the right side, I've got plus 71 and minus 103. 103 is going to win. The negative's going to win. There's more negative than positive. And let's see, what are we going to have here? This will be 29 to 100 and 3 more. Looks like it's going to be 32. So I think negative wins by 32. Negative 32. And so there we are. We've combined the x's. We've combined the numbers. Notice now, of course, like we want in our final answer, we only have x's on the left and plain numbers on the right. Okay, the last thing to do here is we want to get just x on the left. So this negative 40 times I get rid of by dividing by negative 40. Of course, have to do that to both sides, so here it is over here. The 40s cancel out. The 2 minuses give me a plus. So I end up with the plus 1x. I can just write it as x here that I wanted. Now notice on the right here, the 2 minuses combine to give me a plus. Now, we can do some reducing here. It's okay to leave the answer as a fraction. Even if we started with decimals up here, you can go whatever works the best on it. Let's see, 8 will go into both of these. 8 goes into 32 4 times, and 8 goes into 45 times. So we end up with x equaling 4/5. Now, you could write that as a decimal if you want, or leave it as a fraction like this, and there we are. Okay, well, we've demonstrated to you how to clear out decimals and how to clear out fractions. We're going to bump into some of these as we continue on, but now let's look at some of these problems that you're going to have in the homework here as you practice on this. Okay, here we go. Here's the first example. Notice no fractions, no decimals, so we don't have to worry about that. Also, there's no parents, so we don't have to use the distributive laws to clean anybody up. we can just jump directly here to reminding ourselves what we want for the answer. Since the variable is k, I'm going to want to have k equals whatever number the final answer is. So let's identify who has to move. I only want terms with k on the left, so the 4k is okay, but this plus 1 has to move. Remember, no sign in front of it, we assume it's positive. Over on the right side, we only want numbers. Well, the 10 is okay, but you see the plus k? It has to move. So now we move these guys that are on the wrong side. The plus 1 goes over to this side as negative 1. It's been moved. The plus k goes over to this side as negative k. It's been moved. Now let's see what's left. Plus 4k minus k gives me positive 3k. And on the right, 10 minus 1 gives me 9. Okay, well, once you've moved everybody, then the only thing left to do is either multiply or divide to get the final answer. And since we have 3 times k here, how do I get rid of 3 times? I do the opposite. I divide by 3, but I have to do it on both sides, so let's write that down. The 3's cancel out here, so we just get k on the left, and of course 9 divided by 3 on the right is just 3. So there's my final answer, exactly in the form where I wanted it. Okay, well, here we go. Some parents to work with, but fairly simple on this one. We only have parents on one side, so first let's clear out the parents. I've got to take and use the distributive law and distribute the 6 in. 6 times b is 6b. 6 times negative 6 is negative 36. The right side, nothing to do over here, so I just rewrite it the way it is. Now notice why we had to get rid of the parents here is so we knew exactly how much of each term we had. Now we know that. Okay, well now we can remind ourselves where we want to go in the answer on this. The variable here is b, and what I want to have is b equals whatever number the final answer is going to be. So we use this again as a guide on who to move. The 6b on the left is okay. B's on the left are fine, but I only want b's. I don't want any plain numbers, so the minus 36 has to move. On the right side, I only want numbers. Well, the negative 84 is fine, so I can leave it exactly where it is. So we only have one guy to move here, the negative 36. Let's move him. He becomes positive 36 when I jump him over. So we've got a total of 6b equals, well, negative's going to win here, and it's going to win by, let's see, what's it going to be here? I think 48, huh? 78, yeah, 48, so negative wins by 48. And now, since I have 6 times b, I've got to divide both sides by 6. Let's do that. The 6's cancel out here. That's exactly what I want to have. I end up with 1b over 1, which is simply b equals, and notice we have one minus sign, so the answer is going to be negative here. And of course, 6 reduces into 48. 8 times, 6 times 8 is 48, so 8 over 1 is just 8. My final answer, b equals negative 8. Okay, well, a little bit more involved in this one. Notice on the left side here, we don't have any parents to get rid of. On the right side over here, we do have some parents to get rid of, so we're going to use the distributive law and take and distribute in this plus 4 into both of these guys inside. So I have plus 4 times y, which is plus 4y, plus 4 times plus 2, which is plus 8. Don't forget now, there was also this single y on the left, so you got to write him in here. Okay, so at the moment, this is where we are. Nothing to do on the left here, so I just rewrite it. But this is something else that will often happen. Notice, these two terms on the right are like terms. So we can do some further cleaning up before we start solving. So this plus 1y plus 4 more y gives me 5y on the right, and I have a plus 8. And notice on the left, I have 5y and plus 8. Now, this is a very interesting equation. You'll run into some of these as we go along further in the algebra here. Both sides are exactly the same. When this happens, you end up with what's known as an identity equation. Let's show you what happens as you continue to solve this. Let's say that we didn't notice they were both the same here. Now, our goal, of course, in solving this is y equals whatever number the answer happens to be. Well, we would normally go and just identify who we have to move. Anybody that's not a y on the left has to move, so the plus 8 on the left has to move. Anybody that's not a number on the right has to move, so the 5y has to move. Okay, these are the folks we have to move. Let's move them. The plus 8 goes over as negative 8. The plus 5y comes over as negative 5y, so we've moved both these. Now let's see what we have. Well, on the left, 5y minus 5y gives me 0. On the right, 8 minus 8 gives me 0. Real hard to solve for y when you don't have any y's left. But of course we saw up here that both sides were the same. And if you kept solving, this is what happens. Well, when you end up with both sides being the same like this, 0, 0, and no variables, that means you have what's known as the identity equation. And what happens here is officially any value of y would work, because since the sides are the same, and any value you plug into both sides, they'll still be balanced. So when you get the identity equation, the official answer here is all real numbers. Y equals this. And these type of equations never occur in real problems, but you can bump into them in math books like this. And if you ever got an equation that did this in a real problems have a real answer, you'd know that you didn't have the correct equation. Okay, well now you know what happens when both sides are the same and this identity business occurs. Okay, let's look at another problem here. Here again, we've got some parens that we've got to clean up before we start. This time it's the negative 7 in front that we have, so we have to distribute that into both. Let's do that carefully. Negative 7 times negative 1 gives me positive 7. I'll put the plus to rub that in. Negative 7 times negative 3 is positive 21. And of course we've got the n here. Okay, I've used the distributive law to clean up the left side. No parens anymore. The right side is just a plain number, so I can just copy that down the way it is. Okay, well, there's no like terms to combine here. This is a plain number, and this is a variable. So we're as clean as we can be here now to get ready to start doing the solving on this. Okay, once again, we remind ourselves what our goal is. We want n equals whatever number the answer happens to be. So, who do we have to move? Well, the 21n is okay on the left, but the plus 7 has to move. The number on the right is okay, so we leave that the way it is. So there's only one guy to move here. The plus 7 comes over as negative 7. Plus became negative, so it's moved. I now have on the left side the plus 21n, and over here on the right side a total of 147 negative. Okay, well, one last step to solve this. We got to get rid of this plus 21 times, so I divide by 21. I do it on both sides here. The 21s cancel out. I end up with n equals. There's a single minus sign over here, so the answer is going to be negative. And I think 21 goes into 147 7 times right in the button, doesn't it? 21 once here and 7 times here. So 7 over 1, my final answer here, n equals negative 7. And of course, that's what our goal was. Now, of course, we can have cases where we have more parens that we have to get rid of. Here we've got 2 sets of them on the left. So you just spend a little bit more time cleaning things up. Let's go ahead and do that. The first set of parents here, the negative 3 in front has to be distributed into both the guys inside, so let's do that. Negative 3 times m is negative 3m. Negative 3 times plus 6 is negative 18. Okay, we've got a second set of parents. We've got to clean it up too. There's a negative 6 in front. We distribute that in. Negative 6 times 1 is negative 6. Negative 6 times positive 8 gives me negative 48. And don't forget the m that's here. Now, the right side, of course, is just a plain 27, so we just copy it down. Well, before we go on here, we've got some like terms to combine. So, notice both these guys have m's. We can combine them. And the other guys here, I'll put a double underline under them, are plain numbers. Well, you can't start solving until you've combined like terms. So let's do that. Negative 3m and negative 48m is going to give me a total of negative 51m. Here that is. Negative 18 and negative 6 combines to give me negative 24. Here that is. And on the right side, of course, we still have the 27. Okay, well, we've got this all cleaned up now as much as we can. Once we've got it set like this, we can start solving. And of course, let's remind ourselves, our goal here is to end up with m equals whatever number the answer happens to be. We use this to remind ourselves who we have to move. M's are okay on the left, so the negative 51m is good, but the minus 24 doesn't have any m's. We've got to move it because we don't want numbers on the left, we only want numbers on the right. The 27 over on the right here is okay, it's a plain number. Okay, well, the negative 24, if we jump it over the other side, the sign changes, it becomes positive 24. So now let's see what we have left. On the left side, negative 51m, and on the right side, looks like 51. Well, guess what? The last thing to do here, we're dividing, or we have negative 51 times m, so we got to get rid of this negative 51 times. Divide both sides by negative 51. Here we go. And the 51s cancel out. The two minuses give me a plus. I'll write the answer over here where I got a little bit more room. M equals, and now notice on the right side there's a single minus sign, so here it is. And of course 51 over 51 just reduces to 1. So our final answer on this, m equals negative 1. Of course, that's what our target was, so we've accomplished that. Okay, now let's take a look at some guys with fractions once again. Here's definitely a guy that you'd want to clear the fractions out. There are fractions all over the place in this one. And if you tried to solve this keeping the fractions, it'd probably drive you nuts doing it. But let's figure out what the LCD is. And we've got to look at everybody again because we're going to multiply all the way through by that LCD. Now, here's the idea. What we do is pick the largest denominator and start looking at the multiples of it. Why do we pick the larger one? Very simply, we get the answer quicker, which is a very good reason to do it. Now notice something else. You see these 3's? 3's will always divide into any multiple of 6. So the real question here is the battle between the 4 and the 6. So let's concentrate on that. The first multiple of 6 is 6. 4 doesn't divide evenly into that. The second multiple of 6 is 12. Does 4 divide evenly into 12? Yes, it does. And of course the 3's divide into 12 too evenly. So we see here that our LCD in this problem is 12. Okay, well, what you do now is go through and multiply each and every term by 12. Again, I like to do it and circle it up here so I can double check that I've hit each and every term once and only once. Notice, 3 terms on the left, I hit each term once. 1 term on the right, I hit it once. Okay, now, if this is the correct LCD, it will take out all these denominators for us and we'll end up with an equivalent equation much easier to solve. Let's now reduce the old denominators out. 3 goes once here and into 12, it leaves a 4. So that's the leftover I've got here. 4 goes once here and into 12, it leaves 3 on this one. 3 goes once here and into this 12, it leaves a 4. And over on the right side, 6 goes once here and it goes twice into 12. So I've reduced the denominators against that LCD that I'm multiplying each of these guys by. And now we can simply go back and put the leftovers together. Let's do that. Officially, there's a plus in front of this first term. So plus 1 times 4 times x is just going to be positive 4x. I can put the plus here to rub it in, but we could leave the plus off if you wanted. The next one, negative 15 times 3 is negative 45. So there's the next term. The term after this, plus 1 times 4, is just going to give me plus 4. Moving over on the right, negative 17 times 2 is negative 34. Okay, this is what is known as an equivalent equation. It has the same answer as this guy with all the fractions, but now it's much easier to solve. But before we go on here, we do have to combine some like terms. Remember, anytime you have like terms on the side, you must combine those before you start your solving. So I've got the 4x out in front. I'll leave the plus in front of it. But negative 45 plus 4, negative wins by 41. So this will be negative 41 equals over here negative 34. Okay, I've now got this guy absolutely as clean as can be, so I'm ready to solve him. And the key again here now is remember what our goal is. X equals whatever number the answer happens to be. So this is our guide as to who's on the wrong side. We only want x's on the left, so the plus 4x is okay, but this term that's a plain number has to be moved. I only want numbers on the right. Negative 34 is a number, so it's okay. So there's only one guy here that's on the wrong side, this negative 41. So I move him over to the right by changing his sign and making him positive 41. Okay, he's been moved. So on the left side, we just have the 4x. You could keep the plus in front or leave it off. Folks will assume it's positive. Over on the right side here, positive's going to win, and it's going to win by what? Looks like it wins just by 7. Okay, well, here we go. I have 4 times x. I want to get rid of 4 times, so divide both sides by 4. Here we go. The 4's cancel out. I end up with x equals, and can't reduce to 7/4, so that's my answer right there. X equals 7/4. Okay, well, let's take a look at another guy with some fractions, but here's a little something else we have to remind you about. Okay, there are 3 terms on the left here. One of the terms is just a plain whole number, it's just the a, there's no fraction with it. When you figure out what the LCD is, you have to hit every term on both sides, including anybody who doesn't have a fraction. So, to try and make you remember that, here's what I like to do. Make a fraction out of anybody that's not a fraction simply by putting a 1 underneath. Now it looks like a fraction, and hopefully you remember that, yeah, you have to multiply it by the LCD just like everybody else. Well, the LCD is not hard to see here. It's between 2 and 3, and the first multiple of 3 doesn't work, but the second one, which is 6, the 2's will divide evenly into. So very simply here in this one, our LCD is 6. So what we're going to do is multiply each and every term. Now, that includes this guy in front. He has to be multiplied by the 6 just like all the rest of them. So that's the one important thing you want to remember. The reason for this, it's a balance scale thing. When you multiply through by an LCD or a power of 10, if you're clearing decimals, you must hit each and every term on both sides once and only once. You've got to do that to maintain the balance. Okay, well, let's clear out the fractions now and get our equivalent equation so we can solve this. Well, notice the first guy here doesn't have a denominator other than 1, so okay, nothing to reduce here. So the full 6 remains up above. That'll be our leftover we'll use in a moment. Now, the next guy, I reduce the 2. 2 goes into 2 once, it goes into 6 3 times. So there's a 3 left from this original guy up on top. Same thing happens in the next guy. 2 goes into 2 once here, it goes into 6 3 times here. And on the right side, I reduce the 3 out in the bottom. 3 goes into 6 twice up on top. So all the denominators are gone. They're all ones. Now carefully go back and put the leftovers together to get your equivalent equation. Well, this is plus a times 6. Remember, the full 6 is still here. So I write that as plus 6a. Then I have plus 3 times 3. That's plus 9 for the next guy. And then I have negative 7 times 3. That's negative 21. And over on the right, negative 11 times 2 is negative 22. So carefully go back and put your leftovers together. Now, we're not done cleaning up here. We have some like terms to combine on the left side. These two guys are plain numbers, so we better combine them. The 6a is all by itself, so I'll put down the plus 6a. But plus 9 and negative 21, negative is going to win by, well, let's see, what's it going to be? I guess 12, huh? So negative 12. So I combine these two guys. Negative wins by 12. Over on the right side, no combining to do here, just a single guy, so we rewrite him. Okay, now we got ourselves all cleaned up, ready to solve. Now, here we go. Remember again, what's our target here? A equals whatever number the final answer is going to be. Okay, we use this to figure out who has to move. A's are okay on the left side, so the plus 6a is good, but this minus 12 is on the wrong side. Over on the right side, we only want numbers. The negative 22 is okay. So the only one that has to move is the negative 12. He comes over as positive 12. So he's moved. What's left on the left side is 6a. Over on the right side, negative wins by 10. So there is our answer on the right side so far, negative 10. Okay, one more step to get the answer to the equation. This is 6 times a, so I've got to divide by 6, but to keep the balance scale, I have to do the same on the left. The 6's cancel out here. I end up with a equals. There's a single minus sign, so the final answer is going to be negative. And you can reduce this. Don't forget, you must reduce fractions if you can. 2 goes into 6 3 times. It goes into 10 5 times. So my final answer here is going to be negative 5/3. A equals negative 5/3. Okay, well, for our last example to look at here, let's visit the decimal situation. Okay, now, this guy has just 2 decimals here, but they are of different numbers of decimal places, and that makes it a little bit messy. You could solve this keeping the decimals, but I'm going to go ahead and clear them out here to remind you how this works. So, first, look at all of the terms on both sides and find the term that has the most number of decimal places. Well, the guy that has the most is this guy on the left, 2 places. Okay, well, to move the decimal point 2 places and make a whole number out of this, we've got to multiply through by 100. So it's going to be 100 we're going to multiply each of these terms by. Now, here's the thing to remember again, and why this example is important. You have to make sure that you hit each and every term on both sides by this 100, even if it doesn't have a decimal. That's because we have to preserve our balance scale. Well, this one over here, we have to multiply it by 100. It's a term. Then this term plus 3.4x, we've got to multiply it by 100. And the last term in the end, the plus 2, we've also got to multiply it by 100. So the key again here is you've got to hit each and every term once and only once. Even if it doesn't have a decimal, you hit it. And if this was LCDs that we're hitting fractions with, If you had any term that didn't have a fraction, you'd have to do the same thing. Make sure you hit each term on both sides once and only once. That's to preserve the balance scale. Okay, let's apply this multiply by 100. I can see I've clearly hit all the terms on both sides here. Multiplying by 100 moves the decimal point 2 places, so I end up with negative 686. You could put the decimal point at the end, but it's a whole number now, so you can leave it off. Now, the next guy over here, don't put a decimal point and a couple zeros, heaven's sakes. What's 1 times 100? Just 100, so just go ahead and multiply that out. Now, the next guy, however, has a decimal place, so since we're going to be moving it 2 places, I'll put a 0 behind the 4, so when I multiply by the 100, I move it 2 places. So I end up with plus. This will now be 340. The decimal point will be at the end. I can leave it off, just write it as a whole number, but don't forget there's an X there. There it is. Okay, now the last guy, there's no decimal, just multiply it. 2 times 100 is 200, so plus 200. Okay, now, before we move on, the first thing is we've got some like terms on this right side that we've got to combine. Always look for this before you get ready to solve. If there are any like terms on either side, remember you only look at each side individually here, then combine them. Okay, well the left side just has our negative 686. We just rewrite that. On the right side over here, 100 plus 200 gives me a total of 300. So there it is. Officially a plus in front. You could write the plus if you wanted. And then, of course, don't forget the plus 340x. Okay, well, we're all set now. All we have to do is solve this thing. And so, as usual, let's remind ourselves here of what our goal is. We want to end up with x equals whatever number the answer happens to be. Okay, let's identify who we've got to move. Well, on the left side, we only want x's. Well, guess what? This is not an x, so this has to move. It's a plain number. On the right side, we only want numbers. Well, the 300 is a number. It's okay. But you see the plus 340x? It's on the wrong side. We have to move it. So these are the guys that we have to move. Let's move them. Okay. The minus 686 comes over as positive. I'll put the plus to rub it in here, 686. It's been moved. The plus 340x has to come over to this side as minus 340x. There it is. Okay, plus 340x went to minus 340x. Okay, let's see what we have left here. Okay, on the left side we have minus 340x. That's the only thing that's left on the left. On the right, we got to combine these two guys. So if I add 300 to this, I'll get 986. Okay, well, thing left to do, we've got to get the x all by itself. This is minus 340 times x. So I've got to divide both sides by minus 340. Here we go. Okay, the 340s reduce out. The two minuses give me a plus, so I've got x equaled. Now, there's a single minus sign, so it's going to be negative. Well, let's see. They can do some reducing here. Don't know how much. Let's see what can happen. They're both even, so the first thing I know is I can reduce a 2 top and bottom, so let's do that. 2 goes into 340, 170 times, and 2 goes into 986. Well, let's see. 2 goes into 9 4 times. We got 18. 2 goes in 18 9 times. 2 goes into 6 3 times. So here we are. I had 170 on the bottom and 493 on the top. Okay, well, guess what? This guy's not even anymore, so we can't reduce by a 2 anymore. And I don't think there are any other things we can probably reduce on this. So I think this is the final answer here. X equals negative 493 over 170. Okay, well, there we go. We've shown you a number of examples and how to clean up equations that have decimals and fractions. We'll, of course, be seeing a lot more of this equation business as we go on and start solving some real problems later on.